Greetings. Today we are going to be talking about a timer or a PWM signal generator using STM32. Now let's begin. Okay, so if we want to start with our objectives, let's take a look at them. So we have to generate a precise PWM signal using timer 2 channel on our processor, which is the STM32F401RB, and if you wanted more detail, the TX version. So we have to configure TIM2, control the duty cycle by regulating the pulse, and finally to observe the waveform. So now let's start with the hardware. So first on STM32, we have to enter our processor, and then once we enter the processor, we have our IOC diagram, or in layman's terms, a simple processor diagram. And in that, we have to go to any kind of port you like. In this case, we choose PA0, and we have to choose the TIM2 channel 1, which is our timer channel. And after that, you have to go to the timer and then its properties, and you have to modify the pulse to exactly half of the timer's duration. Assume that we have it for 1000, the pulse will be 500. And so here we have a completely detailed overview of STM32, in which what we use it is for not only regulating the timers but for doing other processor related operations. And now we have the code. So basically after we finish the IOC file and all the configurations, we generate the code. And once the code generation is done, we have to just add these 3 lines, as you can see, which configure our timing. And then what you have to do is you build it, generate the hex file, and then we have to execute it. And so here you have each of the parameters. So basically after we execute it and run it for 1 pulse duration, which in our case is 500 for 1, then what we have to do is we have to change the pulse duration, let's say 600 and then 700. You can change it to any pulse duration you like. For example, you can do it for 500, 700 and 900. Basically any ratio below 1000. And so this is basically an entire summary of the procedure that we've given. And here we have the variations, which shows each of our ratio and the oscilloscope display, which we will be seeing soon. And so it shows how much the ratio is closer to the original value. And finally, we have a conclusion. So what did we learn overall? We learned about implementing a PWM signal and about the duty cycle verification and technical competency. Now we will just see a very short overview on the working. Now let us observe the working of our experiment. So now we have our processor right here, our STM32F401 RBTX processor. And as we can see, we can choose any of the pins here. I've chosen PA0. When you click on it, you will have various kinds of inputs and outputs, but since our motive is to generate a PWM signal, and since it deals with timers, we have to choose timer 2 CH1, which in simple words is timer 2 channel 1. Once that is over, we go to timers and we can see our timer 2 right here. And when we click on this, we can see that the source is our internal clock, and our objective here is through channel 1 we have to generate a PWM signal. So once we configure this, we now go to our parameter settings, and we can see that our counter period is 10,000. Now you can change it to 1000 or whatever you like. but 1000 is more or less recommended. And then we come to the most important part, the pulse. And in the pulse, you have to change it into a number that is below the counter period, such as 500 or so on. And then what we have to do is we have to slowly increase the number such that it is below the counter period. And it could be in any ratio you like. It could be 500, 600, 700, or 500, 600, 800. You can do it in any ratio you like. And once we configure this, we generate the code which will look something like this. Now you may ask, where do we add those 3 lines of code? Well, it's right here. So once we add these 3 lines of code and once we debug it, we generate the hex file, and then we go to the next software, Proteus, where we're gonna see a simulation of this. And as you can see, we have our processor right here. What you should do is click on it, and then you have to upload the hex file right here. And then we collect our pin, which is PA0, to an oscilloscope, which is an instrument that shows waveforms. So we've connected it to A. So then what we should do is we must run it. And so, as you can see, you can see these waveforms right here. Now what you can notice is that now I kept it as 9000. So as you can see, each waveforms are very close to each other, but every time the number decreases, let's say 500 or 700, these really tiny gaps will start to widen. And so that is the observation we can make every time we modify the pulse. And so our objective is complete, where we have configured the processor, generated the code, and we have observed the waveforms, and therefore our overall objective of generating a PWM signal using a timer and its channel is complete. Thank you.